Students, in this video, we will learn the importance of studying the properties and specification of T distribution with the difference between two dependent or correlated means. Let us begin with properties of T distribution. The variable T distribution ranges from -infinity to +infinity. The constant C is actually a function of nu pronounced as nu, such that for a particular value of nu, the distribution of f of x is completely specified. Thus, if f of t is a family of function 1 for each value, when the standard normal distribution is greater than 1 and approaches as 1, the number of degrees of freedom is increases. Therefore, the sample size becomes very large. Thus, the variance of the T distribution approaches to the variance of the standard normal distribution as the sample size keep on increases. It can be demonstrated that from an infinity number of degrees of freedom, when nu is equal to infinity, the distribution and normal distribution are exactly equal, which is one among the same. Hence, there is a wide practice comes into the reality that the sample size becomes large when n is greater than 30, which can be considered to be a larger sample size. In such circumstance, we cannot able to apply the T distribution, and the standard normal distribution can be appropriate method can be used for the T distribution. The two important characteristics of T distribution are a T distribution curve is lower at the mean and higher at the tails than a normal distribution. Here, the interval width from T distribution has a proportionally greater area than the normal distribution. The interval widths from T distribution are wider than those based on the normal distribution. Paired design. The control group and experimental group should be paired or matched in some way. This pairing is typically based on the same population, such as similar characteristics or being the same individual measured at different time points. Dependency or correlation. The paired observation in the control and experimental groups should be dependent or correlated. This dependency arises because the same individuals or matched pairs are being compared. It is important to account for this dependency in the statistical analysis. Randomization. The assignments of individuals to control and experimental groups should be done randomly or in a randomized control trial designs. Randomization helps ensure that any observed difference between the groups are due to the intervention or treatment and not other factors. Pre and post measurements. The control and experimental groups should have pre and post measurements of the outcome variable of interest. The pre measurement serves as a baseline or initial values, and the post measurement reflects the values after the intervention or treatment. Normality assumption. The difference between the paired observation should follow an approximately normal distribution. This assumption is very important for the validity of the paired T test. Here, the sample size is large enough, typically over 30. The normality assumptions may not be critical due to the central limit theorem. Homogeneity of variances. The variance of the difference between the paired observation in the control group and experimental groups should be approximately equal. Here, this assumption is known as the homogeneity of variance, and it's assumed that the importance of the accuracy of the T test. Absence of outliers. Outliers in the data can have a significant impact on the result of the paired T test. It is important to check for an outlier before conducting the analysis. By ensuring these conditions, one can conduct a valid paired T test to compare the means of the control group and experimental groups and evaluate the effectiveness of the treatment. The T table. The T table gives the probability value of T distribution. It is given over a range of values of nu. The probability of T distribution has a different value for each degrees of freedom, and when the degrees of freedom is infinitely large, the T distribution is equivalent to a normal distribution, and the probability shown in the normal distribution table are applicable. Here I have explained the various importance of properties in T distribution of the control group, experimental group, and finally the importance of studying the T table for the two dependent sample or correlated means. We will continue in the next video. Thank you.